In this problem, we have a circuit diagram. We are asked to find the equivalent resistance RAB and the power delivered by the source. Our source is this 5 amps, but first we're going to look at all of these resistors and try to combine them into a single resistor. That way, we only have to look at one resistor when we're calculating for our watts. And it also asks us for the equivalent resistance, and the equivalent resistance is the total of all our resistors. So to start this out, we should note the direction of current. This can really start anywhere. I like to start from the left-hand side to make things simple. If we draw our current, it's going to be going down this way, and we can see that once it hits this node right here, it is going to be in parallel with this 144 ohm resistor and this 12 ohm resistor right here. However, this 12 ohm resistor is going to be in series with this 25 ohm resistor and this 4 ohm resistor. Since it's in series, we're going to use the series equation where we just add these together. So we're going to get 41 ohms of resistance here. This 41 ohms of resistance is going to be in parallel with this 144 ohm resistor, since these two resistors are going to combine and basically be right here. That way we can see that it is in parallel. The parallel formula is just 1 divided by our resistor, which is 144, plus our other resistor, and we have 1 divided by 41, which we just found, raised to the negative first power. If we do this, we get 31.9 ohms of resistance. So I'm going to rewrite what we have. So we've gotten rid of all of the resistors over here, combining them into one 31.9 ohm resistor. So we can just write this here. Now, after we do this, we can see that this 5.6 ohm resistor is going to be in series with our 31.9 ohm resistor. So we're just going to add these two together, and we get 37.5 ohms of resistance. We know that this is in parallel with this 12 ohm resistor, so we are just going to put these two values into our parallel resistance formula. So we're going to get approximately 9 ohms of resistance, and this 9 ohms of resistance is in series with this 2.5 ohms of resistance. We can show this if we combine all of our resistance here. It's basically going to be this resistor right here, this 12 ohm resistor. We're moving everything into this resistor. And if we run our current through it, we can see that it goes up this way, and then it goes through this way. And then it goes up here, and then back this way. That's why it is in series. So we're going to add to our 9.09, 2.5 ohms of resistance, and we get 11.59 ohms of resistance. This is going to be in parallel with our 15 ohm resistor, and that is because the current splits at this highlighted node right here. If we do this, we get 6.5385 as our resistance, and this is going to be the total resistance for this entire block right here. Now, after we do that, we can see that this series is going to be in parallel with our 10 ohm resistor and our 14 ohm resistor. So we can just add them together. If we do this, we are going to get 30.5385. Now, that is going to be in parallel with this 60 ohm resistor, so we'll just use the parallel equation for this. And if we do this, we get 20.2379 ohms of resistance. That means that this is the total resistance, so this is RAB. Now we're going to look at power. The power formulas that we know are linked below in the notes in section 2.3, and they are as follows. We have these three formulas, all are derived from each other, but we need to look at what we have in order to do this. We have resistance, we know that after solving for our RAB, and we also have current right here. So we need something that's current and resistance. Something that has voltage in it will not work. That means this formula and this formula will not work, so we have to use this formula. If we plug in our values, we're going to get that P is equal to our I squared, and our I squared is just 5, and this is being multiplied by our resistance. I made an error in the formula. Instead of having a division there, it should be times. Only the second equation right here has division. So we have I squared times R in our resistance we just found to be 20.23 ohms. If we set this equal, we're going to get 500.75 watts of power. Since we are delivering power, it says delivering right here, it's important to make this a negative 505.75 watts. If it absorbs, it would be plus. And that is how we do this problem. If you have any questions, leave them in the comments below. If you want to go back to basics, they will be the first link in the description. If you want more mid-tier problems, they will be the next link. And if you want more advanced problems, they will be in the third link. If you want more material like this, there will also be a playlist linked below. And if this helped you out, consider leaving a like. I would appreciate it. And good luck on your studies.